Can you hear me all right in the back? Okay. So I'm Jim Fulton. I'm from Zope Corporation. And I'm very happy to be in Argentina. I'm happy the weather's great today. It's nice to see you all. I apologize for not speaking Spanish. I wish I did. Someday maybe. Okay, so what I want to talk about a little bit today is a common mistake we make when designing APIs of trying to do too much. And there's a lot of there's a justifiable good desire to try to make things as easy and powerful as possible, but a lot of times less is more. So I just wanted to walk through some examples of that. So we're going to look briefly at the Zope 2 publisher, the Zope 3 publisher, Python, the config parser from the Python standard library, and to be a little bit different, we're going to look at an example from a JavaScript library. So, how many people here have used Zope or Plum? Okay, wow, not that many. Well, Zope had its beginnings in a project called the Python module publisher, which had sort of a friendly name of Lobo.
Sorry about that. Just quickly, Control Q the application. Yep, there you go.
So, in many ways, Zope, when it first came out, was kind of like, for that time, what Ruby on Rails was when it came out. It was something that allowed you to create applications very, very quickly. Going back before that was something called, again, the Python module publisher, and it was based on this idea that you should be able to take any Python module and somehow put it on the web, make its information available on the web. And in many ways, you can think of it as kind of a science project. At the time when you wrote web applications with Python, you did so with the CGI module, and it was very tedious. You basically, called very low-level APIs, and you had to do a lot of work to do something fairly simple. So, the Python module publisher basically tried to make that as easy as possible, and as an experiment, it was a really successful experiment. Basically, the idea was it treated the web as a collection of objects, and you could associate an object with the URL. So if you had an application on the web, the URL path was mapped onto an object access, and as you traversed the URL, you would do things like get attributes of objects, or get items in dictionaries or mapping objects. And then once you found an object, Bobo would figure out how to call the object. It would introspect the object's arguments. Typically, the object was a method or a function, and it would figure out what names the object expected, and then it would satisfy those names from request parameters, either using things like form variables or CGI-defined variables or headers or cookies or whatnot. And that really worked well, and it was very successful. And it allowed people to be very productive. But it had some downsides. In order to do all of that, it had to have some basic rules. And the basic rules were conventions that if an object didn't start with an underscore, and if it had a docstring, then it was public and accessible and should be used. And if you knew about those conventions, well, first of all, if you're only doing an experiment in the lab, it didn't really matter. But if you knew if you were actually creating applications and you knew those conventions, it was still really pretty easy. And in those days, docstrings were still kind of new, and so it was unlikely that you'd sort of accidentally encounter something with a docstring that wasn't meant to be accessible. Over time, some additional hooks were provided. For example, an explicit protocol was provided to be able to control how that was done, so that you could have additional rules, and then a whole bunch of different additional hooks were added over time to deal with things like database and transaction management and error handling and other sorts of things. But ultimately, and in fact, the legacy of those decisions are with us today in Zope 2 and Plug, and occasionally there are hiccups. So was that, so did that really cause problems? Well, in the long term it did. In the long term, it probably was better to be more explicit than we were back then, even though the initial result was very successful. Having sort of rules that you have to know is a burden, and the reason it's a burden is that people have to know what they have to learn what those rules are, and they have to remember what the rules are. And I think a lot of times, especially in systems that sort of follow the convention over configuration philosophy, I think they underestimate the load that those conventions have. People have to think about them, they have to remember them, they have to pay attention to them when they should be paying attention to their app. Okay, so moving forward a little bit, we have what I in an earlier slide referred to as the Zope 3 publisher. In the Zope community, we're trying not to talk about Zope 3 too much because the goals of the Zope 3 project ended up not being to replace Zope 2, so it ended up not making any sense to call it Zope 3 anymore. But old habits die hard. But the new name for it is the ZTK, or the Zope Toolkit. And it has a publisher that was based on the Zope 2 publisher, and it tried to apply the lessons that we learned in the Zope 2 publisher about making things more explicit, but it ran into some other issues, which I'll describe. So very similar to Zope 2, there's this notion of traversal, which is based on this idea that you start with an object and then you traverse it to get to other objects. If I have time at the end of the talk, I'd like to come back to that since Alan mentioned it in his talk. And then we call objects. There's some other features that I didn't really describe that are kind of useful in a way, but maybe not so much, that it also provided. I was reminded of those when reviewing the code the other day and preparing for this presentation. And in the case of the Zope 2 publisher, we had a bunch of hooks that you had to provide in various sorts of, not always convenient ways. And so I tried to provide a more rational way of plugging the behaviors. And in particular, it made publication much more explicit. So we were still publishing objects and their methods, but we were being a lot more explicit about how we did so, which is a good thing. So the basic architecture is that you have the publisher itself, and in these days we use Whiskey, so the publisher also has something that adapts it to the Whiskey framework. And you have request response types. These are the kinds of things that you typically have with web frameworks. And then to provide application control, we had a plug-in component called a publication object. And the publication object basically embodied all of the hooks that we had accumulated over the years in the earlier version of the publisher. And I won't go into detail. It's not real, the details aren't really important. This is an API that a publication object has to implement. These publication objects really are probably not the sort of things that you would write if you were writing an application. They were the sort of things that a higher level framework might provide. So for example, we have one of these that's geared towards storing your data in the Zope object database. But you can have a different one for storing in a relational database, or perhaps a different one where you don't store anything in any database. Perhaps in some ways the most interesting or the most controversial being get application. Remember, with Traversal, you sort of start at a root object, and so this method got you the original object to start traversing from. The API is not very interesting, really. You can sort of argue with it. You could argue that we made lots of mistakes with it. You could argue all day about that. It's not really the point of the talk. And so the API itself isn't that interesting. Now, the way this should have worked, the sort of essential complexity of this problem is that you should define your application, and you should be able to just plug it together with the publisher in a fairly straightforward way, using in modern days, WSGI assembly tools like, for example, paste deployment. But it didn't turn out to be that way. Now, how many people have seen it? How many people do web here? Okay. And how many people have used paste deploy? Oh, not that many. Okay. I'll address that. So anyway, paste deployment is this little tool for gluing WSGI. How many people know what WSGI is? Oh, okay, a fair number. Okay, that looks like pretty much all the web people know what WSGI is. So this is a typical kind of configuration for a WSGI-based app that uses paste deploy. You have some configuration for your application. You have maybe some middleware, and then you have some configuration for your server, and it's pretty straightforward. Defining your application. As I mentioned before, you'll typically use, if you were to use this framework, you would use some sort of standard publication object that you would instantiate for your application. And it's traversal based, and traversal is actually kind of controversial. It's kind of fun to talk about. If we have time, we'll talk about it more later. So we made a couple of mistakes that really made the publisher not very successful, even within the Zope community. So the original publisher, otherwise known as Bobo, was actually wildly successful. The Zope 3 publisher was sort of imprisoned in a lot of infrastructure that resulted from some mistakes that in part involved doing too much. The first mistake we made was that you want to configure everything. And that, in retrospect, was a really silly mistake to make. At the time that we did it, within the Zope community, people were crying out to be able to configure and change a lot more. And then we also had this notion in Zope of supporting many different kinds of requests. So we could support, your standard HTTP requests. We could support XML RPC. We could support SOAP. We even got a little nutty and used this framework to support things like FTP. And not only did we do that, but we tried to free the application developer from having to deal with the details of doing that. So we wanted to do that for the application developer. So as I mentioned, we have this, in the Zope 3 publisher, we would do this dispatching very, very early in the process. So when a request came in, really before it even touched any application code, we'd introspect the request and figure out what kind of request it was, and then we would dispatch to different kinds of application components based on the request type. And the main advantage of this is it's kind of cool. The sort of lesser advantage of this is that you can have a single resource that exposed itself under multiple protocols. And I suppose in a sort of a RESTful way that I could see where that would be attractive, although we did this long before REST was fashionable and possibly in existence. But that ended up making things really complicated, especially from a setup point of view. There's actually a simpler way we could have done this, which we've actually done in some of our applications at Zope Corp, where we wanted to have some special processing for AJAX requests, and that is to simply wrap your resources in some sort of decorator or function that knows how to do that. So, for example, in a tiny little framework that we use at Zope Corp to deal with AJAX methods, we have a wrapper, and that wrapper deals with things like, AJAX-specific error handling and response marshalling, and someday we're going to probably switch this. The sort of standard procedure in AJAX calls that most frameworks seem to use is to pass data to the call as form data and to get it back as JSON. I prefer to send JSON, but we haven't actually done that yet. But a little wrapper like that can sort of automate the details of handling that. So, our Python functions are really nice, especially for AJAX, where you don't have to deal with pointy brackets. AJAX, I really like AJAX because you're just moving data around. It's just like traditional method calls. And in fact, when you reason about an AJAX method with a framework like this, it's just like reasoning about a regular Python program. You don't have templates, I hate templates. So wrappers are a really nice solution for dealing with different request types because you can pick your application, you can pick your wrapper technology, your sort of means of dealing with the request details. You can pick that independent of your web publishing technology. If you want to do it in a particular way, or maybe you want to innovate, it's not all tied up with the publisher. In fact, over the years, I've come to really like things that are highly decoupled. I'd like my different web technologies to be independent of each other. I'd like to use something for publishing, maybe something else if I have to generate pointy brackets, or maybe something else if I want to deal with the database. I don't really want all of those to be tied together in one kit. I'd like to be able to pick them independently, and it's actually really easy to do. The only real downside of this approach is it doesn't really make it convenient to have the same resource of it, support multiple protocols at the same URL. But that's really not a problem that I have. So I just talked about that. So how did we fail, in terms of the publisher, and just to a lesser degree, well, to much the same degree in terms of the Zope 3 project. We focused too hard on replacing Zope 2. So when we designed the publisher, we were focused on reproducing what we had before, rather than really thinking about what the best solution would be, for that particular time and place. We overused the component architecture. So we made everything. We made it so you had to plug everything, rather than making it so it was possible to plug everything. People really wanted everything to be pluggable, but they wanted things to be easier a lot more than they wanted everything to be pluggable. So anyway, I've talked about request types. I don't think I need to belabor that anymore. The component architecture is a really powerful plugin system. If you need plugins, if you find yourself thinking about writing a registry or some sort of mechanism for plugging things into your application, I encourage you to take a look at the Zope component architecture. I think it's a nice general solution. Of course, you should only use a plugin system if you actually have a good reason to have plugins, because plugins have a burden. People have to. They introduce indirection. They introduce sort of emergent behavior. They can introduce surprises that is sort of a downside. In fact, I would argue that all abstraction is bad. All abstraction is bad. It introduces indirections, it introduces complexity, it introduces non-locality. It's always bad in my opinion. But it also has lots of good things, and in many cases the good things outweigh the bad. But you should always realize when considering using an abstraction that you're carrying some bad along, and you better make sure that the good significantly outweighs the bad. So it would have been a lot better if the publisher could have been customized optionally without forcing people to deal with plugging or components. So the main lesson here is that when considering features in an API, make sure you understand what the relative benefits and costs are. We have a saying around Zope Corporation. Well, actually, I'm not sure it's a saying, but we have kind of an expression non grata around the Zope Corporation, which is "I can imagine." You'll be in a discussion with engineers, and you're considering a feature, and somebody will say, "Yeah, but I can imagine." And usually, that's a bad thing. When somebody says "I can imagine," you should shut them up right about that, because that's usually a bad thing. Pluggability should have been optional. Okay, so I'll switch gears now to look at something that's in the standard library. So config parser is a library that I get the sense a lot of people sort of love to hate and yet love, because it's a really simple format and a really simple model, and simple has a lot of appeal to it. But it's kind of a funny implementation, and people love to re-implement it in various ways. I actually really like it a lot. I think it's pretty versatile. It's actually kind of trendy because it's schemaless. I've noticed that schemaless is kind of a trend these days, and it's kind of an interesting one. But schemaless feels a little bit to me like the dynamic typing that we have in languages like Python and JavaScript and Perl and so on, and that it frees you from dealing with a lot of, when something has a schema, you have to tell it about the schema, and you end up spending time on the schema rather than your application. So schemaless things are kind of appealing in that regard because you don't have to do that. There's still a schema. Your application started out as a configuration language for Grail. How many people know what Grail is? Yeah, Grail was a web browser developed by the group that later became Python Labs, Guido et al. At CNRI. And it was used as a configuration language in that, and it started out as being an RFC 822, which RFC 822 basically means, how many people have seen like mail and HTTP headers? Okay, well, if you ever look at one, that's what the configuration syntax started out being. And then it kind of grew with other projects at CNRI, and eventually was incorporated into the standard library. And so it has a kind of a crufty history where it started out being something quite different and sort of evolved to the place it is now. By the way, it's actually gotten a lot better in Python 3.2. So it's much saner now than it was in the previous version. I think maybe partly because of the blog post I wrote last year. Maybe not. Anyway. So how does config parser get in the way? Well, for one thing, it really doesn't polish some things that it might polish, like really defining its syntax well. Until recently, not really providing a sane API. So really what you want is you want to parse some configuration text. Ideally, you should be able to parse text. I don't know if the current config parser lets you parse a string. And then get back something that behaves like a mapping of mappings. So you should be able to use, get items, square braces with it, and get values out of it really easily. It also does some things that actually make it hard to use, like it strips values, and sometimes you don't want the values to be stripped. In fact, as I mentioned a moment ago, in build-out, which uses it, you really want to retain the relative indentation of value of multi-line values. So in build-out, we'll often use, how many people have hit build-out, used build-out, or know what it is? No, not too many. Well, you got to find out. It's work, but it's worth it in the end. Sorry, the documentation is kind of bad. I tried. But in build-out, we'll often have, within an option value, we'll have snippets of configuration from other configuration files that build-out will end up generating. And sometimes the indentation is significant and it's lost because config parser strips values. There's actually, I just learned in researching for this talk that there is actually an inline comment syntax in config parser. I don't know when it entered config parser. Maybe it was always there, but it was undocumented until I think until like Python 2.7 maybe, or maybe Python 2.6. And I imagine some build-outs have been broken by that. I'm not really sure. And it's actually been removed in 3.2. The defaults and variable substitution are actually optional, but they sort of invite usage, and their usage causes pain. So, for example, if you use paste deploy, which is a tool that I like to use, if you have percent signs in your configuration, you end up having to escape them because it uses this variable substitution syntax. It doesn't really come into use all that often. I mean, it supports it, but I really don't think it's used that often. And then there are lots of optional features that are on by default that you have to bother to turn off. It's doing a very simple thing, and it's very handy to have something that does that simple thing. But you actually have to work a lot harder than you should in order to use it. And for some things, there's some things that you just can't work around without not using it, which the newest version of build-out actually doesn't use it anymore. So, a lesson here, amongst the lessons is don't be a captive of history. So, it would have been a good thing if when they decided to add config parser to the standard library, they had stepped back and thought, okay, well, this is kind of cool. We used it at some projects at CNRI. What should this really do? What sort of model should this provide? This is a little bit similar to the mistake we made with the Zope 3 publisher, and maybe we shouldn't have tried to reproduce all the features of Zope 2. And then if you're going to try to help somebody, have sensible, you can have sensible defaults, but make it easy to change them. A lot easier than config parser does. So config parser, I still use it. I like it. But and the version of Python 3.2 is a lot better, but it could have been a lot simpler and actually more useful if it was simpler. Okay, so I'm going to switch gears a little bit and talk about a JavaScript library. This is actually going to be one of the best examples of what I'm trying to talk about in this talk. But Dojo is a high-level JavaScript library. I like it a lot. It's far from perfect, but it's really nice. That, the thing I like about the modern web is that we don't have to implement applications with HTML anymore, or at least not directly with HTML. And so with libraries like Dojo and UE and EXT, you get to write at a level at which you might be accustomed to if you use like desktop GUI libraries like Motif, or I realize that's dating me pretty badly, but WX Windows, I guess Qt, I don't know what the current ones are. But anyway, it's a very nice high-level library. It allows you to write applications much like you would write a traditional GUI application. It also provides lots of useful facilities for doing low-level web programming as well. You know, things like dealing with styles and animation and lots of other things. I just want to talk a little bit about their animation API because it's a little hard to use, and it could be a lot easier to use if they just emphasized and documented a core part of it. So the animation API, the Dojo animation APIs, there are actually a bunch of APIs, but they all are based on a base API, and the base API was actually abstracted from a bunch of sort of evolved APIs. But the base API is very simple. So with animation, what you want to do is you want to create a visual effect, typically to help users perceive a transition in the application. So, for example, in a mobile app, when you go from one screen to another, there's typically some transition, so it's very visible that you're going from one part of the application to another. Or, you know, there are lots of reasons why this might be used, but they're very commonly used to represent some sort of transition. And typically what you do is you might change a color or change a position or make something appear or disappear over some short period of time, like maybe a third of a second. And so the Dojo animation, hopefully, just out of curiosity, how many people here do JavaScript? Oh, a fair number, okay. Well, JavaScript is fairly easy to read, at least if you don't, yeah, well, anyway. So here, basically what you do is you create an animation object, and you tell it to play. And you give it this option called curve, which is kind of an oddly named option, but it really is just two endpoints. And the reason it's called a curve is that what Dojo actually does is it constructs internally it constructs a curve in sort of the values and time, and it has various options for controlling the shape of that curve. But basically, you know, you want to start at one point and end up at another point, and you want to spend some time getting there. And most of the time, you don't really care about the details. And if you do care about the details, there's some options to deal with that. And then what will happen is that you supply a function, and that function will be called with values from this range as they're computed over that period of time. And there are things like frame rate and things that controls how often your function gets called. And then your function's job is to simply translate these values into something, anything you want. In this case, we're rotating an element. I apologize for the source slipping off the slide. I didn't catch that when I was reviewing these. But basically, it's setting a CSS style. It happens to be a CSS style that is currently implemented in sort of, not browser specific, but browser specific in the sense that you have to use a different style name on each browser. So a more practical implementation would be slightly more complicated than this to deal with the difference between browsers. But basically, you're computing a style property that says rotate the element. And this, if you were to run this on a WebKit browser, whatever node you pointed it at would rotate in a circle over a period of about a third of a second. So it's actually pretty straightforward, and it's very easy to reason about. So you can look at this and you can see very easily what it's doing. Now, Dojo doesn't document this API, except it mentions it. It mentions it a lot, but it never actually tells you what the API is or how to do it in their documentation. What they document instead are some higher level APIs. For example, if you look at the Dojo animation, if you were to Google for Dojo animation or Dojo FX, you would first learn about fade in and fade out, and wipe in and wipe out. So as you can imagine, fade in or fade out, let's say, makes an element sort of slowly disappear by becoming transparent, eventually disappearing. And fade in does the opposite. Wipe in and wipe out basically causes it to sort of disappear from one side to the other. So it's like somebody wiped a rag over it. And these are kind of nice effects, but when you're designing a web app, you know, okay, but what else can you do? You know, like for example, in the wipe in and wipe out, you don't really get any control over what direction. You know, like I wanted to do it, I needed to use this in an app, but I needed to, I forget, I think I needed to have it go from top to bottom rather than right to left or something, but there was no easy way to get from that to what I actually needed. They've got this slide to, which is really kind of bizarre in terms of how hard it is, because it basically says, take some element and move it from where it is now to some other position. And the way that they specify the position is kind of strange. And then they have a more general API for animating properties, and this is a little bit closer in that you've got some property and you've got some node and you can specify one or more properties and just tell it to animate those properties from where they are now to some where you want them to be, or you can provide starting and ending locations. So here you say make the width 300 pixels. That's wrong. It should be units, isn't it? Maybe it assumes units. I don't remember. From whatever it is now, and here we basically say, okay, well, change the height from 100 to 400, and change the font size to 14 point from wherever it is now. And this is sort of straightforward, except that sometimes you want to do something even a little bit different than that, and that doesn't work with the rotation example that I gave, because the rotation CSS property or the transform CSS property is more complicated than just an individual numeric value. So if we compare the Dojo animation API, and I suppose I should have picked an example that was exactly the same, but I was too lazy. But here we've got an animation, and we've got the animate property. Animate property is a little bit simpler. It's not that much simpler, especially when what you want to do doesn't actually work with animate property. And now you're like, okay, now what do? Well, you start reading the source, and that's kind of complicated. And boy, it's just kind of hard to figure out how to do it. But even if you know what all those APIs do, and they do exactly what you want, if you use the high-level APIs, depending on how you count them, you have to remember 4, or if you want to count the ins and outs separately, you have 7 APIs to remember, whereas the animation API is really just one API to remember, and it's just easy to remember. Slide 2, it's not as obvious what it does. And the high-level APIs are less powerful. Like they couldn't handle the transform case. Turns out they sort of could if you knew to load a special extension from the Dojo X module or from a particular Dojo X module that knew how to deal with that property. But if somebody came up with another property next week that package didn't know about, well, then you'd be out of luck. Because it really, ultimately, it doesn't fit the model of a simple numeric value. So anyway, a simple versatile API that maybe required a little bit more typing, I would argue would have been better than a collection of high-level APIs. What's somewhat ironic here is that the low-level API exists, but it's unloved by its authors. The Dojo folks really sort of feel like it's too low-level. People should use the higher-level APIs. But I really think they're missing the boat there because they don't appreciate the load that those extra APIs carry in terms of extra things that the developer has to know. And also a very simplified interface like the fading interfaces or like the wipe in and wipe out makes something that's fairly simple kind of complex and mysterious and inflexible. So why do people make these mistakes? Well, history is a big factor. We start with sort of a point solution for a particular application and we generalize it. And when we generalize it, we kind of sometimes forget to generalize the goal. The goal is to solve some general problem, because that's why we generalized it. It's no longer to solve my applications problem. Also, admirably, there's a desire to make things easier. But the mistake is often to make things easier by hiding details, or to make things easier by doing too much. So in the Dojo case, they made things easier by hiding a bunch of details. But then if the abstractions that they provided didn't work, it was very hard to find abstractions that would. I think to some degree in the Zope publisher cases, or in the config parser, there's a tendency to mistake that they actually do too much. And I think a lot of this comes back to goals. A common problem we have when talking about software is we talk about solutions, but we often forget to talk about what problems they solve. And quite often when people argue about solutions, they're arguing about solutions to different problems. But in any case, when designing a library, it really helps to be clear about what your goals are. And I think if these had been a little bit clearer, things would have gone a little bit better. And I'd like to emphasize, in particular, in the light of something that I wanted to agree with something Alan said earlier, that I think documentation is really important. And more importantly, I think goal-driven documentation is really critical. So when designing an API, you should identify what problem you're trying to solve. So your API has some user, the person who's calling the API, and they have some goal, some problem that they're trying to solve. I find it very instructive to actually write a how-to describing to your audience how they're going to use the software to achieve their goal. I find that when you do that, you see problems that you don't see otherwise. It's kind of like Alan's example of having somebody read the document back to you. A little bit different. Anyway, so enough of that. So anyway, that's all I had to say. Any questions?
Could you go back a couple of slides, please?
Sure.
Just to the one where...
Yeah, we're fine.
One forward again. Yeah, so when you say goal-driven rather than solution-driven...
So,
I recently gave a talk to the Django users, and I criticized their documentation because it doesn't consider the audience's purpose.
Right.
Is that the context?
Yes. So we have a problem, and the problem that we have in Zope Corporation that I'm trying to correct, and it took me a while to recognize it, is that when engineers talk about software, they tend to focus on, talk about software requirements or software user interfaces. They talk about the software because that's what they love, right? That's what we create. We create software. Our software is beautiful, just like our children. And so when we approach the user interface, really the user interface is all about letting somebody get to our beautiful software. But really the purpose of software is to solve problems. So the user has some problem they want to solve, and what we should be thinking about is how they use our software to solve their problem. And when we think about it from the software's point of view, we sort of think about ways of making it convenient for the software and convenient for our elegant architecture. But really we should be thinking in terms of how the user is going to solve the problem with the software. We've been trying to do this at Zope, and we've used techniques like making somebody, whenever we're designing a new feature, we write a how-to for the feature, where the how-to is all about, if it's well written, how does the user achieve what they want to achieve. So it's a different point of view. It's looking at it from the user's point of view rather than the software's point of view. Any other questions? Okay, well, thank you.